So moving on to machine learning and physics machine learning, what's the difference for those who don't know?
So machine learning can be considered in a way as a scattergun effect. It takes data from things that are going on, and as I say, these gigabytes of data going up to the cloud. You can take all of that data and then you can infer certain bits of data and understanding from that. However, physics machine learning is the thing that allows you to really, as I just described, hone in on the actual solution much quicker. By comparing a constraint bounded scientific model, it allows you to remove the irrelevant data effectively. So whilst you may have a lot of data coming up to the cloud, for example, looking at a time taken between two locations, which is what you may use to infer an expected journey time, for example, in a navigation application, there will be some instances where clearly people stop, for example, to have a stop at a service station, and that actually makes their data look like they were moving far slower than they in fact were. Physics machine learning allows you to have a model which picks up and measures the constraints, that if average speed drops or minimum speed drops below a certain level, you can infer that the data has stopped effectively, and therefore you can remove that from your data set. So it allows you to get much more use and much more relevant data, and to reduce the chance of essentially going off in the wrong direction by misinterpreting data that you have available to you.
Can you give me an example where having more data directly improved system efficiency or decision making, or a use case? It doesn't have to be a client case.
Indeed. I mean, clearly, an example is with an electric car or an electric yacht or ferry or something, you'll always be sizing the battery to the right. You have to size the battery to the right condition. The battery obviously is a very expensive piece of equipment. It's quite heavy, and therefore, if you install a larger system than you actually need, you end up wasting money, costs as well, from the fact that you're consistently carrying around that heavier mass with you. So by using machine learning to get a really good operational use case and load case and a model for how this vessel is actually operated, for example, it allows you to much better size that. And it's just simply, I hate to say it, but it's all about efficiency. It's more efficient if you can make sure that you fully understand the load cases and the use case of your piece of equipment. Then you can size it and save significant costs and space. And again, it's the carry on. It's that virtuous circle where if you make a battery smaller because you understand how it's going to be used, you then have less mass. You then have the battery going further, which means you can make it smaller again effectively. So really, use of understanding the data and understanding the technical application that you're trying to solve really is key. And the more knowledge you have on that, the more informed decisions you can make.